Hello and welcome. Many thanks for being with us today, and it's a great pleasure to welcome Dr. Volker Steinbiss and Dr. Evgeny Matusov.
Yeah. Hi, Agnieszka. Hi, Lukasz.
Hi.
Hello. Yes, you're both from Aptec, so maybe you can start with telling us what your roles at Aptec are.
Yeah, I'm the managing director of Aptec in Germany, and we also have a few people working out of Valencia, where we have a subsidiary. So I try to make sure my scientists here it's the science team of Aptec located here in Europe. Make sure that they can be productive, and otherwise I have a sales and business development role. And my scientific background, I started as a scientist, is automatic speech recognition, and then I also looked into speech translation. So that's the special form of translation where you start from audio.
I worked on machine translation for over 20 years already, and this is also my role at Aptec. I lead the MT team, so research and development in this area for text and speech translation, and in particular also machine translation for dubbing purposes.
Thank you for that. And we're aware that at Aptec you offer various services, for instance, automatic video translation. And I was wondering, Volker, if you could perhaps give us an overview of how this offering works. And we'd love to hear what are the steps involved and the technologies you use to offer this comprehensive service of automatic video translation.
Okay, well, from the distance, it looks very simple. So you basically concatenate three technologies that are available. Let's say you dub from, say, Chinese to English. You start with ASR in the source language. Say you, when I say you, I mean the machine. So the automatic system transcribes it. Then you have the transcription. You translate it with machine translation, and then the translated text in the source language is being synthesized. So that's the basic pipeline. And of course, there are a few, say, things to take care of. One is the time markers. It's important to know when the text starts and ends. It's even also important to know where the pauses are, but that's, say, a higher level of sophistication. So let's say first the time markers. Then the system wants to preserve the original voice. For example, if two people speak, you want to differentiate who is the first and who is the second person. And so when you look into it, it's a concatenation of speech recognition, machine translation, and text-to-speech or speech synthesis. But then there is a lot of, say little things that count as well, like the speaker diarization on the source side, who stops speaking, who's the next speaker, the identity of the speaker, mapping it to the voice in the target language, the timing, and the length of the translation, so everything fits time-wise. And you start with a video, there is music in the background, so you have to remove that music and mix it in again later. So there's a lot of sophistication, and it's actually, I would say, the most complex pipeline we have ever built, the dubbing pipeline.
Sure, that sounds impressive, and I understand the key challenge is how to combine all of these technologies because they are available separately from various providers. So what you do, you combine them together.
And it has to be really good, right? So when you start with a little mistake in the beginning from the ASR, so you get one word wrong, and it's a semantically completely different thing, and then it rolls through the system, and the MT makes something horrible out of it, and then you have to listen to it. It's really bad. Let's say the difficulty is that you have to excel in every step, and everything has to go together very well.
And the advantage of Aptec is that we develop all the technology in-house, basically. Speech recognition, machine translation, TTS. We can customize at all levels, starting from very deep ones like systems architecture and to the coupling of the different components, making sure that the system, for example, MT can accept spoken variants of digits and also produce possibly spoken variants for better pronunciation and text-to-speech and other things like that. So This is the advantage. Instead of using just out-of-the-box systems from third parties and trying to couple them somehow, we do it at a much deeper level and can have a much better quality because of that. The main three components which Volker mentioned is not the only thing, and actually speaker diarization segmentation is often underestimated. We currently focus on improving these components because yes, they are really important. They affect the processing in the subsequent steps. We can integrate glossary, so we can add words to the lexicon of the speech recognizer so that those words are properly recognized, especially names. We can add also glossary to machine translation so that the right terms are used. We can also go further and adapt on some text data from this particular domain, let's say some environment or some very special where we know in advance what the topic will be. And even we can do things like improve the text-to-speech, because for text-to-speech, actually, in my view, it is very exciting that the voices sound natural and maybe emotions are coming in, but as soon as you get a wrong pronunciation or wrong stress on the word, this whole effect is kind of destroyed, in my view. And this is something we'd like to avoid. So, for example, we work a lot on something what is called word level language identification. So basically making sure that foreign names are pronounced the right way in a given language. So, for example, James Webb is not pronounced James Webb in German, but actually the way it should be pronounced. And also these terms can be added with proper pronunciations for text-to-speech if we know in advance that certain people will be talking. Their names should be correctly also pronounced in the dubbed version.
It's a complex interaction. So in particular, say, simple minds who think there is a technology coming, let's save on personnel cost and do everything automatic, they will just fail, right? So the technology is very powerful in terms of scaling. It's very powerful in, being fast or so, but it still has errors, right? There is this illusion or fantasy that you start with a specification from what the customer wants. Of course, we want to know what the customer wants, perfect dubbing, right? But you can't have that, full stop, okay? And so you have to see what the technology can do, and then you have to find the market where that makes sense. And interestingly, should I go into that? Because we have this, ASR, MT, TTS, and then some extra components. So what you could do is you have ASR and then post-editing. You have, for example, an English master template and then all the MTs and then etc. You could do a part fully professional. You could do it with post-editing. You can do it fully automatic. There are many options. And commercially, from my point of view, there are only two options that at this point in time are commercially viable. So one is the say extreme quality. That's basically the post-editing starting from a perfect script in the target language. So still, either human generated or post-edited or so. And then you can reach very good quality. And then still you might choose, to start with documentaries and not with highly emotional, say, content. And then there is the other extreme, fully automatic. Why would one go for fully automatic? Well, if you just don't have time, if you want to have, say, more or less live dubbing or so, in many languages right now, and people are just interested in the content, and from time to time, just something that doesn't work well, that's the way to do. So these two extremes are what is currently really interesting. And then, so it's basically technology. Then you have the commercial aspect. There must be a way to earn money, because otherwise companies like ours wouldn't exist. We have to make a profit somewhere. And then what is easily forgotten is the professionals. So it makes a huge difference from my point of view, and that's probably where people like you come in. Makes a huge difference how you roll this out. Is it that you roll out a fully automatic system believing it works, and then people clean up the mess? Or is it that people have a tool and they basically have everything under control and they are responsible for the quality, and then they use the tool depending on how good it works or so. That's a very important aspect. And then other important aspects, rather than this, who is under control, is the quality aspect. So even if you have a fully automatic system, you can pre-tune it. That's what Evgeny mentioned. And I also mentioned. The technology is the same, whether you feed it with material from the domain, but the point is we have, it's all machine learning. So that term is often used, right? One term often used is artificial intelligence, the other one, machine learning. These systems learn from data, and they are better if they have data that are representative of the task, simply said. So the quality is much better. Imagine a system transcribing our dialogue and then not knowing how to write our names. It would be quite cumbersome to read the text, right?
Yes. Before I move on and ask a big question, just a tiny question about improving pronunciation, something that you, Volker, just mentioned and Evgeny mentioned a moment ago, about improving text-to-speech. Do you use the IPA for this, or how do you go about that?
The lexicon, is IPA, yeah.
The IPA, okay. So
yeah.
Just asking in the context of whether it makes sense for linguists to learn International Phonetic Alphabet, is it useful or not?
I think it is, yes. I think it is. It makes things easier also to
it's like
modify. So even at this point, we have a possibility for human in the loop to actually change the pronunciation of certain individual words or phrases, make more stress on one or the other, change the actual phonemes, and for that it is good to know what phonemes are available, what can be used. Yeah.
Yeah, but I hope we talk about higher levels than learning.
Yes,
it's a little like should people have a driver's license, or should they put that to the
morning? That's a low level question. Okay, let me ask a higher level question then. We were talking about what machines can do, what they can't do, and I went to your website and watched the video with Casablanca, and I was quite impressed with what you said.
And I always say, this is the last piece of content you would ever automatically dub, because it's such a precious thing. Of course, this is just to, to showcase what you can do, right?
Yes, and in speaking about what the system could do, I was thinking about the dubbing specific requirements, for instance, related to the duration of the utterance. I could see that you could make some adjustments.
Yeah, that's super important.
Some metadata, or how a machine translation should translate, whether that should be an informal form with do or with the more formal z, right? So Evgeny, I don't know if you want to discuss this a bit, maybe?
Yes. Yeah, so our MT systems, they support additional controls, basically what we call metadata aware controls. And we actually think that this was a first step that we did already a few years ago, before all this LLM-based hype started, where you can now control a lot with prompts, but then you don't really know what is a prompt, say, not even discussing that large language model may be an overkill or like a very big one, which you cannot run for your system, for dubbing. But even if you do, it's not clear what type of prompt you want to use. Would it always work well, and so on? We have a more kind of standardized way of setting the right style, for example, or controlling lengths through explicit API parameters in our system, for example. And yes, we have features to control the formality. I guess this is mostly known in advance, what should be the formality level for a certain movie or scene in a movie. We have a way also to control for the right gender forms, so the morphological gender. We can pass this information on from the speaker diarization system that detects the gender from speech, for example. And then the right forms would be used in languages like most Slavic languages, like also Polish, for example, also Romance languages, which have gender-specific verb and other forms.